In this question, we're asked to look at the components of a solution, decide if they're acidic or basic, decide what the change will be when we add something else to the solution, whether it'll change the pH to make it higher or lower. And in order to do this, we need to be familiar with strong acids and strong bases. And I just want to first say that this is not a definitive list of all strong acids and all strong bases. Different sources have slightly different views on what a strong acid and a strong base is, and because strong is a qualitative word, right, there's no exact definition for what makes something strong or weak, and that's why these kinds of things happen. So for your strong acids, we have HClO4 perchloric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, and sulfuric acid. For our strong bases, we have 1A metal hydroxides, lithium, sodium, and potassium. You would also have things like probably rubidium hydroxide and cesium hydroxide as strong bases as well. However, these things would be very expensive and uncommon, so these are your common strong bases. Even lithium would be too expensive for us to use, for example, in a general chemistry lab. We would use sodium or potassium because they're cheaper and they essentially perform the same function. Other strong bases, calcium hydroxide, strontium hydroxide, and barium hydroxide. Notice here that magnesium hydroxide is omitted. Magnesium hydroxide is actually in milk of magnesia, which people actually drink, and it's hard to say that something we drink is a strong base, and because it's not very soluble in water. If you remember, 1A metal hydroxides are soluble in water, 2A metal hydroxides are somewhat soluble, but magnesium hydroxide is not very soluble in water, and that's what makes it a weak base. So again, these are a list of 6 strong acids and 6 strong bases according to one source. You could find different things in different places. However, these will help us to solve this problem. So as far as I could tell, these were all the examples that were given here. So let's look at the first example. The initial component of the solution is water. Well, we all know water is neutral. Then we add sodium iodide. Sodium iodide is just a salt. It's not an acid or a base. Hydroiodic acid is a strong acid. So I minus is an incredibly weak base. Said another way, sodium iodide is just a salt. It's not going to change the pH. Adding salt to water does not have a significant change of the pH. Water and KOH. Well, KOH is a 1A metal hydroxide. It's a base. So therefore, if you have water and KOH mixed together, it's going to be basic. KCl. Well, KCl has Cl minus, which is the conjugate base of a strong acid, hydrochloric acid. This is just a salt again. So the pH is not going to change if you add a salt. Water. As we talked about before, of course, water is neutral. Add HI. HI, hydroiodic acid, is a strong acid. Strong acids make the pH lower. Remember, pH is 1 to 7, essentially, except 7 are acidic, and then 7 except 7 to 14 are basic, and then exactly 7 is neutral. Water and KOH. Well, again, KOH, 1A metal hydroxide, is a base, so this solution is going to be basic. If we add HCl, HCl is a strong acid. So even though this solution is initially basic and has a pH higher than 7, if we add acid, it will go down. Depending on how much acid we have, it might go down below 7, or it might not, but it will certainly go down from where it is, so the pH will be lower. So that's basically how we want to approach this particular problem.